Right, right. Very cool.
Yeah. And then the second thing, I guess the second P to so pool, packaging, and processing. So we already talked about the pool and how it helps optimize your omega-3 pool and omega-3 to 6 ratio. And then on the packaging, so the packaging is interesting because, and on the pool, by the way, the main part of the SmartPrime mix or composition that's doing that is the sesame seed lignin complex. So
Mhm.
it's basically extracted for this complex of lignins that are really doing most of the heavy lifting there. And those compounds are things like sesamin, sesamolin, sesamol, and episesamin, right? So it's this complex of lignins at a high enough dose that within that 250 to 500 milligram dose of SmartPrime, you're getting anywhere between 60 to 120 milligrams of those specific lignins, not just of sesame seed oil. So
Right,
that's important. And that's what's doing most of the work on the pool side of things.
right.
Then on the packaging, so what our IP is protected for, our patent applications talk about all ways that improve your methylation status. So, maybe your audience has probably heard um, about like methylation, right, and how important it is for various, processes in the body, the liver and the brain specifically, right? Um, your methyl group metabolism and how your body handles like one carbon metabolism is governed usually by your folate status, your vitamin B12 status. You could also improve it by adding betaine or trimethylglycine. Um, those are like methyl donors. And then, of course, vitamin B6 and B12 are also important as part of that whole, like, methylation cycle, right? The way that your body transfers these methyl groups, from one molecule to another in various biochemical pathways. And that's important for different reasons. One, it's like first neurotransmitter metabolism, like in order for you to be able to move from having enough norepinephrine and dopamine, and even to some extent serotonin, it's often governed by your ability to be able to methylate. Um, Methylation is also important for gene expression, right? We're hearing a lot these days about like epigenetics,
Right.
and epigenetics is largely governed by adding these methyl groups or these chemical tags to your DNA to be able to sort of repress which genes are being transcribed or activated and expressed, or to have other areas that allows the promoters to be open and allows these genes to be expressed and activated. So brain neurotransmitter metabolism and being able to make the right amounts of the right neurotransmitters where you need them
Mhm.
is dependent on having good methylation status. DNA, control of epigenetics and gene expression. Um, Also important for liver health in terms of the liver has to do a lot of, transferring of these methyl groups between different compounds in order for the liver to do its thing, if you will, in detoxifying, phase one and phase two detoxification pathways. Methylation is also really important in keeping your homocysteine levels under control as well, right? So homocysteine is an amino acid that we find in the body. It's usually from methionine metabolism. And if you don't have sufficient methylation status in your body, your homocysteine levels tend to go up. If people also have like an issue with like a SNP in the folate, like tetrahydrofolate reductase, like one of the enzymes that allows you to utilize folate effectively, you can also see those homocysteine levels go up. And homocysteine is associated with cardiovascular disease, stroke, ischemic disease. It's really not good for the lining of your blood vessels. So you want to keep homocysteine levels down as low as possible. Whenever you're engaging in things that might affect your blood lipids, or if you have a lifestyle that may increase your cardiovascular risk. You want your methylation status to be on point, because you're going to want to do all those healthy things that having a good methylation status allows you to do. And in this case, what we did is we're using MSM, which stands for methylsulfonylmethane. And most people probably recognize MSM. And it's like, wait a minute, isn't that what you find in like joint health products, like glucosamine, chondroitin, and MSM, right? Mm-hmm. And so, yeah, the answer is yes, that's the same MSM. But in this case, we're using it for a very unique purpose or a different reason. We're using MSM in order for it to be a methyl donor itself. It's actually kind of both. It's one of the unique molecules that can do both methyl donation, and it can do sulfur, bioavailable sulfur donation as well. So it's also a great sulfur donor. And we need both in our body, right? We need a good amount of sulfur to do various things biochemically in the body, and to keep the integrity of tissues, connective tissue specifically, extracellular matrix, all that. And that's why MSM has been found to be great for joint health. It actually has itself some anti-inflammatory benefits. And MSM itself is also good for even for skin, hair, nail health as well. Anywhere where you have, where you have collagen that needs to kind of maintain its integrity. Anywhere you have glutathione as well, methylsulfonylmethane can help. There's even a study that I'm aware of that they used MSM in a group of in a cohort of subjects, healthy subjects that were trained to failure. They did like 10 sets of leg extensions to failure with an emphasis on eccentric training, so on negatives, to really cause muscle damage. And they had a placebo versus an MSM group. And the MSM group actually showed large reductions in delayed onset muscle soreness, an improvement in muscle recovery, and decrease in pain and inflammation too. The inflammatory markers went up much higher in the placebo group than in the MSM group.
Interesting.
So MSM has other functions beyond like joint health. It's not just for cartilage. Mm-hmm. And in this case, we're using it to optimize the packaging of omega-3s, of your PUFAs, or your polyunsaturated fatty acids, to make sure that any linoleic acid that you do have, and make sure your EPA, DPA, and DHA that you have is ideally more in the phosphatidylcholine form versus in the phosphatidylethanolamine form. Because in our bodies, fatty acids are typically, they're rarely going to be found in free floating, free form, non-esterified fatty acids or NEFAs. They're usually going to be bound to something, right? Because they're lipids. They're not going to be very soluble in the blood and plasma. So they're usually going to be bound to something like albumin or a protein, or they're going to be in the form of a phospholipid as part of like the outer membranes of every cell, and even some of the organelles inside the cell, things like mitochondria, lysosomes, and some other organelles inside the cell. So it's packaged. It has to be packaged. Mm-hmm. Now, the issue is people that have some insulin resistance, people that are type 2 diabetic, that are obese, overweight, or that have an issue with their methylation status, like we talked about before, they're going to be stuck, usually have an overabundance of all their fatty acids, are going to be stuck in the PE form, which is phosphatidylethanolamine form. But we want to get them to the phosphatidylcholine form, because that's the real business end. That's where then EPA, DPA, DHA, and even LA can sort of play a more functional role within the cell, within the mitochondria, as well as all the downstream processes and enzymes that we need it to. So packaging is very important. And the combination of MSM with these lignans also encourage the packaging of your essential fatty acids to be in the phosphatidylcholine form, PC form. Okay. So yeah, I think that's important when it comes to packaging.
Okay. I just want to go back for a second. I think we talked about this the first time I had a meeting with you. Just like I I don't, because whenever I first read it, I don't think many people know that like omega-3s go through this process to have to become packaged in these phospholipids. So just going through, like, let's say you take fish oil that's in like triglyceride form,
Hmm.
since that's what I'm using for this product. So you
Yep.
take fish oil in triglyceride form. So basically, I think what you said was that happens is it goes through first pass liver metabolism, and then during that first pass, the triglyceride chain comes off, right? So then it becomes a free fatty acid. And then I think after that, it basically undergoes a second pass through the liver. And then through that second pass through the liver is actually when it becomes packaged in that phospholipid form. Is that right?
Yeah, so a couple
Okay.
things. So yeah, overall, I think you've got the gist of what's happening with the fact that anytime you ingest fat or lipids,
Mhm.
it's going to be just through the normal digestion process is sort of that first pass. So it doesn't necessarily get directly it doesn't pass directly to the liver like through portal circulation the way amino acids and carbohydrates do, for example. So, but what happens is, so you take like fish oil, like you said, in the triglyceride form,
Mhm.
you ingest it. But when it gets into the upper part of the small intestine, the duodenum and the jejunum, what's happening is it is cleaving the by using these non-specific esterases and lipases. It is going to be cleaving the EPA and DHA off of the glycerol backbone, right? So you got the glycerol backbone with the three fatty acids hanging on it, and usually at least one or two of them are going to be EPA or DHA when you take fish oil in the triglyceride form. So it's going to clip them off, and then you're going to have these free fatty acids that are kind of floating around, and then they get repackaged. So they get like broken down first in the gut, then they get repackaged, and mostly they get formed into what are known as chylomicrons, and those then get absorbed into the lymphatics actually in the gut.
Okay.
They go through the lymphatic system, and then they get dumped in the circulation in something called the thoracic duct. So they go through like a different pathway than other nutrients do through the liver.
Okay.
So the first passes, they do get broken apart and then they come back together. And then it's not until they make their way back around to the gut after being circulated across from as a chylomicron, when they make their way back to the liver, that the liver is going to see them for the first time. And that's what you were referring to as the second pass.
Okay.
So the first pass is actually happening at the gut mostly, like at
Oh, I see.
the intestinal cells, like the brush border,
Oh,
the small intestine, those epithelial cells, they have a lot of these enzymes there. And there's also a bunch of enzymes being dumped in from the pancreas as well
okay.
into the gut, into the lumen of the gut. So a lot of this is happening like in the small intestine itself before it gets absorbed into the lymphatics.
Okay.
So most fats, most lipids that are long chain fatty acids, right? Anything usually above 12 carbons or so. Even some of the 12s can get incorporated into the lymphatics as well, into that chylomicrons and some of those particles. Most short chain fatty acids do get absorbed very rapidly into the liver directly. So things like butyrate, acetate, propionate, C6, C8, like people are talking about like the C8 medium chain triglycerides.
Yeah.
Those medium chain fatty acids do get absorbed into the liver directly.
Okay.
But
Interesting.
all these others that are long chain, like fish oil, even flax, like the ALA, corn oil, like the omega 6s, LA, linoleic acid, those are all like C16 and above.
Mhm.
And all those fats are going to be absorbed through that lymphatic system, like I was saying. They're called lacteals in the small intestine, and then they drain basically through the lymphatics up to the thoracic duct. They get dumped into the circulation, and then they eventually make their way back into the liver. When they get back into the liver, that's where the real that's where a lot of cool things happen.
Okay.
And that's where they get repackaged again into their phospholipid forms mostly.
Mhm.
And then it depends on what you're gonna have a fate to go into phosphatidylethynolamine, phosphatidylserine, phosphatidylinositol, phosphatidylcholine. The majority should go to phosphatidylcholine if in a healthy individual and a healthy person, right? So that's what happens. And then after they leave the liver, they're going to be in the phosphatidylcholine form as part of either lipoproteins that are floating around, right? Like HDL, LDL, VLDL, and remnant particles, right? Those particles are going to float around to then be able to deliver those fats into the different tissues in the body. They're also being delivered. They're being delivered to the muscle, fat around the body, bone marrow, the immune system. And the important one here, which is pretty cool also, because this drives home the importance of packaging, is the brain.